This is part 8 of PIC game programming, and it's about generating random numbers so that each time the game is played, it'll be different. So the constants required for the random number generation is just one. It's max rand count. So the random numbers are stored in a cache, and a cache of 16 values, and that just defines how many values are in the cache. And then in the actual RAM variables, there's a pointer to the cache to show where we're going to get the next value from, and then a pointer to the cache to show where the next number is going to be generated into. And then just below that, here at address 50 hex in the memory, is the cache of 16 values. Just has it as a placeholder. So everything's going to be, all the values in the cache are going to be relative to this name called rand. So in order to generate the random numbers in the actual timer, just uncommented this line, which was commented out until this point. What it does is every 1/10 of a second it calls this make rand function, and the make rand function just generates a new random number. So a new random number is generated in the cache every 1/10 of a second. So coming on to the two functions, which are probably near the bottom of the code, I think. Because the first function, make rand, so like I say, every 1/10 of a second this will get called. It moves the address of the random cache of numbers into the W register, and it adds the offset that we're currently into the cache of random numbers where we want to generate the value, and it loads that address into the indirect addressing register so that I can refer to it in this with this ind f. So this is the ind f points to the actual value that we want to manipulate, and I swap the nibbles of the current value. So when the application first gets started, in the first part of these programming talks, I spoke about clearing the memory, but I was only clearing 48 bytes, and the reason I was only clearing 48 bytes is if the memory is going to be inconsistent at startup, why not just leave it like that for the random values, and it gives it a bit of a start. They won't be random values, but they'll be undefined, so they could be anything. And what I make the new random numbers up is the value of them timers. So we've got timer 0, and I use exclusive OR to exclusive OR the timer values altogether. But the timer values, the low nibble is always going to be changing a lot quicker than the high nibble. So the high nibbles, if I didn't do this swap nibbles at this point of swapping the last value that we created, then the higher value nibbles could potentially be considered not really that random, or not as random as the lower nibbles. So going around, I use timer 0 as a base number for calculating the XORs, and I exclusive OR the other timer values to it. And the intersect of what timer 0 is to what timer 1 value is going to be changing each time the timers reset themselves. And as the program's getting used, they don't necessarily get set at the same time, so it's fairly random. And then I exclusive OR with what's in the current register, so the value that was first in there from initialization, I exclusive OR the value with. But next time round, so after we've created 16 random values, it'll start over the address 0 again. So actually we'll be also exclusive ORing over the top of the previous values, and that also keeps it nice and random as well. Then I increase the address of the place at which we create in the random counts, so that next time we come in, we'll create it in the next address. And I move that into the max count into the W register, because what I want to do is check and see if we've gone over the top address, and if we have, so this exclusive OR will result in that as a 0, the 0 flag being set if it's actually up at that max count, if our current pointer's at the max count, and if it is, then it will reset it back to the start address again, so it will start generating random values from the start again. So that generating random values will just keep going round and round and round, and the values aren't necessarily being used at all. It could just be keep generating them because it generates them every 10th of a second, but only when actually the user is playing the game, or when we want a random value, does get called. It's only at that point that it decides to take one of the random values, and that could have been overwritten many times before we actually ask for the actual value. So we've got an offset into the random values that we want to get from. So we increment that offset, and then we do the same as when we were creating them, and we want to make sure that that offset hasn't gone past the maximum value. So do an exclusive OR, which will set the 0 flag if it has gone over the value, and just reset it back to the first value again, the first offset. And then after that, get the address of the rand, the cache of rand values, add the offset into that cache of random values of the one that we want to get, put it into the indirect addressing address, and then we just move whatever's in that location for that particular rand value back into the W register, and that returns it. So when we come out of this function, where the program resumes, it'll have in the W register a random value. So the test harness which I test these functions with is back up here. So I've got rid of the old test harness, and this is just custom test harness just for testing the random values, and it's very small. So what it does is it calls get rand value. So I don't have to worry about making them because it's the interrupt that's calling the make rand value, and that's happening all the time, every 1/10 of a second. When you're programming, you don't have to worry about the actual creation of the random values. All you have to do is call get rand value when you want one. I'm just putting that straight into the LED state. So as all the bits in the rand value are random, if I just put it in the LED state, that will just update the LEDs randomly. And then I tell it I want a short pause, and I call pause just to make sure that LED sequence is lit for at least like a 1/10 of a second or half a second. I think it might be half a second. No, 1/10 of a second. And then it goes around the loop again, and it goes back to get rand, and it updates the LED sequence. And so this test harness just flashes the LEDs in a random sequence all the time, constantly. So this PIC device has been programmed with the code, and when I put it into the circuit, it just generates random LED flashes.